This is Mr. Sutton. Thanks for joining us again for another round of radicals. This one, we will be simplifying quotients of radicals, including fractions containing square roots and square roots containing fractions. For your warm-up, take a sec to evaluate these two expressions to see if these are equivalent. All right, you got it? So for this one, we have to take the square roots first. So we've got square root of 36, which is 6, over the square root of 9, which is 3. And 6 over 3 is 2. Here the division appears to be happening first. 36 divided by 9 is 4, and the square root of 4 also 2. Hey, how about that? So our conclusion then, we can move division in and out of radicals just like multiplying. We've got a moving in rule for division and a moving out rule for division. At this point, it's time to revisit our rules for simplest form. So in our last lesson, we saw that we're not allowed to have perfect square factors inside a radical. So for example, the square root of 20 would not be simplified because you can split that up into 4 times 5. But now we're going to add two rules for simplest form. One of these is that we're not allowed to have fractions inside radicals. So for example, the square root of 3/5, no good. We are also not allowed to have radicals in the denominator. So if you had 5 over the square root of 3, also not allowed. But we are allowed to have radicals in the numerator. Radical 3 over 5, totally good. You might be wondering why we care. So the big reason that we care, there's a few. One of them is that back in the day before they had calculators, they found that this situation where you're dividing by a non-radical is much easier than these other situations where you're dividing by a radical or trying to take the root of a fraction. So they liked this better. In modern times, the big reason is that on multiple choice tests, most of the multiple choice answers are going to be in this simplified form. So if you don't know how to convert to this form, you won't be able to figure out what the answer is. Let's begin with our simplest case, which is having a radical in the denominator. So how do we take care of this? Now keep in mind, with all the things we're doing, you're not allowed to change the value of the fraction. There are things we can do, but we're only going to make the fraction look different. We're not actually going to change the value. Now, the number one technique for dealing with fractions without changing the value is to multiply them by some version of 1. In other words, some number over itself. So let's ask ourselves, is there something I could multiply the square root of 6 by to make it no longer a square root? Well, if I multiply the square root of 6 by itself, that would give us the square root of 36, which is just 6. So in general, our strategy then, and because we can't just multiply the bottom, we've got to do it to the top as well, we're going to multiply the top and the bottom of our fraction by whatever radical is on the bottom. So we'll multiply this by the square root of 6 over itself. And again, we're just multiplying by 1 to give this thing a little bit of a makeover. So on the top, we've got 12 times the square root of 6. On the bottom, we've got just plain old 6. Whenever you multiply a radical by itself, you're basically squaring the radical and it goes away. Squaring undoes a square root. All right, don't forget to reduce. And also, if there's any radical simplifying to do in the numerator, you should do that as well. In fact, you should actually simplify the radical before you reduce. But there's nothing to do with this 6, so just 12 over 6 down here gives us 2 radical 6. Here's another example for you to try on your own, so pause the video and see how far you can get. All right, we've got a radical in the denominator. Again, we're going to multiply by that radical over itself. That's going to give us 8 radical 20 over just plain old 20. Now, before you go ahead and reduce here, again, you might want to make sure that this radical is as simplified as it can get. Because if there's more stuff we got to bring out here with the 8, that's also going to get factored into that reduction. So 20, we can split that up into square root of 4 times square root of 5. So that's 2 times square root of 5. 8 times 2 gives us 16. And now we're kind of glad we waited, right? Because now we can reduce this even more. 16 over 20, that's going to reduce to 4 over 5. So our final answer is going to be 4 radical 5 over 5. We're going to do one more example. And I really like this example because it has so many different things that we need to do to make this simplified. So first thing we should ask ourselves when we have a radical with a fraction inside of it is, can we reduce the fraction inside? And in this case, we can. 16 over 6, that reduces to 8 over 3. But we still have this problem of the radical with a denominator inside. We're not supposed to have fractions inside radicals. So what we can do to solve this is use the move-out rule. We can send the 8 and the 3 packing, each with their own radical. So now we have the square root of 8 over the square root of 3. Oh, but now you might be noticing another issue we have. Radical in the denominator. This radical 8's okay, but this radical 3 down here, no good. So we'll multiply by radical 3 over itself. That gives us radical 24 on top. When you multiply two radicals, you just multiply the stuff inside, make it one big radical. On the bottom, we've got 3. Oh, but wait, 24, square root of 24, that is not simplified because we can split that up into radical 4 times radical 6. A square root's in there. Square root of 4 is 2, so now we have 2 radical 6 over 3. Can we reduce this at all? No, we cannot. The only thing you're allowed to reduce here is the 2 and the 3. Some of you might have been tempted to reduce the 6 and the 3, but you have to keep in mind this is not really 6. This is the square root of 6. This is the weird, funky decimal that when you multiply it by itself gives you 6. So that's not going to go into 3 at all. So that's it for this one. Until next time, this is Mr. Sutton signing off. Have a radical day.